But then AI came. AI came, and the question was, oh, so what do we do now? Um, and there are actually, so JPEG looked at it, and there are three ways you can use AI, right, in the field of compression. One of them is to say every codec has a lot of parameters to optimize. So why not having a AI module that, like a good human, will go and tries all the combination of all the possible parameters, but this time without human intervention, and find the best. That's one way to do it. You don't need to change any standards. In fact, what you do is that effectively you make longevity of standards even longer. So a lot of existing standards will have maybe 10 years more to live because they even deliver much better results in terms of rate distortion that was possible. Well, of course, this is something that some people do, but JPEG committee is not there to do that because JPEG just does the standard and specification, and then outside companies, outside universities, outside research centers, they just do these kind of things. So that's not, although it's very interesting path, it's not something that is really meant to be done in a standardization committee. The second way to do that is to say, what about just replacing some of the old architecture, for example, the transform coding or the pre-processing and post-processing, by some AI system? Now, interestingly, JPEG committee decided it doesn't want to go that path. JWET and MPEG are following this path, and there are good reasons to follow this path, but that is not something JPEG committee did. What did JPEG do? JPEG decided to go for a radically different coding architecture. And a good example to illustrate that is the autoencoders, right? So everybody's familiar with deep neural networks, in this case, even CNNs, convolution-based neural networks. And the idea is that instead of having these specific components and some model, you just feed the pixels of the image on one end. It gives you in a latent space, in a very compact version of it. And then you do the opposite, and then you get it back. And if you do these things well, the fidelity between what is on the left and what is on the right through machine learning can become extremely good. And in fact, some people have even been trying to do it in lossless, numerically lossless way. And that's the path that JPEG is following. And so the first thing JPEG did was to look what has happened. And in fact, this path seems to give very, very good results. Again, I don't want to spend too much time on that, but you can see here just through time, since 1992 to 2020, and by looking only the last 3 years, 2017, 18, and 2020, you see that there has been tremendous improvement of learning-based image compression, state-of-the-art in literature, right? So only 4 years ago, 5 years maybe now, the result of compression efficiency, in terms of compression efficiency of learning-based images, was not even comparable to the good old 25 years at that time JPEG. So it was interesting from academic and scientific point of view, but from practical point of view, it was ridiculous. It was giving worse results. But now, actually, results are getting really good. So you can get, since a couple of years, really very, very competitive results, much better than what can be obtained by legacy and let's say model-based coding schemes. Based on this study of the state of the art, JPEG committee started to, in 2019, so 3 years ago, actually, a little bit over 3 years ago, to look at AI-based or learning-based image coding solutions. And because this is how JPEG does, it doesn't rely on publications that are outside. It has to check everything itself. It issued a call for evidence. And in fact, a number of codecs were submitted to it. I don't want to go again to the details of it, but in fact, it turned out that many of these responses that were received were doing better than the best of the best. Not only the 30-year-old JPEG, but anything that is around, HEVC, JPEG 2000, everything that is around, you could get actually through learning-based image coding better results, and not only from objective but also subjective quality point of view. And in fact, as I said, many, like here, I know that through this teleconferencing you won't be able to see it, but even if you could look at it on a very high quality, so this is team 5, team 6, team 7, team 8. So there are quite a few of these ways of using machine learning approaches to do really better than just the best state of the art that thousands of experts have been working on for decades on. Now, something other interesting also came. JPEG noticed that well, AI is also used for a lot of other things in imaging, not only compression, actually more in other things than in compression, right? AI is extensively used in enhancement and in computer vision. And we know that, of course, AI is really the tool for machines to understand and comprehend images. But if we start doing coding for machines, then we tend, and there is a danger of having two codecs, right? One codec for humans, one codec for machines. And we will have two ecosystems, and many applications you don't even know, right, whether it is for machines or not. Look at your mobile phone. The front-facing camera looks at your picture, looks at your face, and analyzes your face, does biometrics, and gives you access to your mobile phone, but you can use it also for selfie. The selfie is for humans, not for machines. The biometrics is for machines. You cannot have two codecs for that. And there are many applications like that you can. So the question is there a way we put both the needs for humans and the need for machine under the same umbrella? And this is the bet that JPEG is doing. So let me just illustrate that. A lot of machine learning based on, in this case, again, deep neural network, is used nowadays to increase resolution and even color content. Here, one example. Image on the left, very old, low resolution, not even color. On the right, higher resolution and color. There is nothing that prevents you do that in the latent states that I said. So in the compressed domain, right? So you just have a compressed domain, and you just replace the decoder, instead of decoding just what is looking like the left, by something that will look like the image on the right in the previous slide. And the same is true for a lot of other things. Machine vision, let's say biometrics. I give you the example of biometrics. Who is this person? There are a lot of machine learning-based methods, deep learning-based methods. Through learning, they learned how to recognize people. Well, there's no reason to do that on the pixel domain. You can do it also in the latent space of a machine learning compressed. So these kind of things you can imagine can be done a lot. So Jpeg AI defined the scope not only as a better compression scheme, but it's a learning-based image coding that offers in a single stream that is compact the possibility of visualization by humans. So it should look good to humans, but it should also allow efficient image processing and computer vision tasks. And of course, although JPEG community cannot emphasize it, its history has shown that when things are royalty-free, they get adopted faster and they remain longer. And that's why there is this desire, although JPEG community cannot impose it, of royalty-free baseline codecs. And this is more or less the block diagram of what Jpeg AI is. On the left, you have the image. It goes through some transform, which is probably a deep neural network, but it doesn't mean that it needs to be necessarily a deep neural network. If somebody says, oh, a spiky neural network is better, well, it will be a spiky neural network. Or if somebody says a GAN is better, it will be a GAN. But in one way or another, there will be a compressed latent domain. And then this compressed latent domain can be processed in three ways. Either through a standard reconstruction that guarantees that what is the input image will appear exactly the same way. That's very important. This path is very important because a lot of artists, a lot of content creators, they do not want that any decoder deteriorates or changes the content they've created. So the standard path will just give something, if not exactly the same, perceptually or otherwise the same as what is input to the system. But then you have two other paths. You can also apply them to the compressed latent representation. You could get better or at least processed content, denoise or enhance or color or in paint and so forth. Or you could do computer vision tasks. Classify, detect objects, understand semantically what is in there, do biometrics, etc. So this triple purpose is really how Jpeg AI has been designing itself. And here I just want to flash very quickly what we mean by image processing and what are the type of things that people are now doing in JPEG community regarding image processing and what is the type of things that people are doing through computer vision tasks. Of course, nobody's saying this is going to be limited to these, but these are the ones that people are looking at in the JPEG community. In terms of use cases, as I said, you could imagine there are quite a few. Many of them, they are good. It is necessary that the content is both good for humans and for machines. So some of them are really coding for machines. Some of them are only coding for humans. Some of them are coding for both machines and humans. And you don't want to create, several codecs for the same purpose. And there is a hope that JPEG AI framework, the way it was defined, the architecture was defined, can actually harmonize and put under the same umbrella all these different use cases. Three use cases, of course, you get requirements. Again, for interest of time, I'm not going to go through them. But one thing I want to show you is that in terms of core requirements, effective compressed domain image processing and computer vision is above significant compression efficiency. Although it's very clear that JPEG AI is going to be better than anything around in terms of existing compression standards for images. It actually above that and before that, the most important requirement is the possibility to have this triple play possibility. There are, of course, others, and there are a number of desirable requirements that probably will give place to some low complexity or some other, low latency, etc. profiles that will be for specific application, as it is usually the case in standardization. Now, what is the work plan? So there is a very, very actually well-defined work plan in January, so not very long time ago, just a month ago, JPEG released its final call for proposal. In fact, in a couple of days, there will be the deadline for pre-registration. I can tell you that there has been already a number of pre-registration received and probably even more by the next 2 days. There will be a number of milestones that have been defined in terms of deadlines to submit the codec. This is the 10th of March, but then later on, of course, submit the material and so forth. Again, for the interest of time, if there are any questions, I can answer, but I don't want to take more than the time that is allocated to me. So I'm going just to tell you that beyond this, the roadmap of JPEG AI is that we will have a working draft in October this year already. And hopefully we will have in 2024, not very far from now, so about a couple of years plus a few months, we will have the first learning-based image coding standard ever. Thank you very much. I just want to maybe stop here. And if there are any questions, answer to them.